Good evening, students. Welcome to Sankalp Learning Classes. Today we are discussing important question answer from the chapter Carbon and its Compounds. Okay. Yes, I hope all are ready to listen the class. Carbon and its Compounds. Yes, dear students, just recall what you learned in this chapter. So, one of the important chapter for your board exam. Okay, so in this chapter first we are discussing the MCQ questions. After that, 1 mark questions and 2 mark question, 3 mark questions, means a short answer questions as well as long answer questions. First we are starting with the multiple choice questions. Let us start with the first question. Number of single bonds found in the molecular structure of propanol is option A 8, option B 6, option C 7, option D 5. Here the molecular structure of propanol. So propane means that is having the 3 carbon atoms and hydrogen like this, and see double bond OH means OH group is present. So alcohol, propanol means it is a alcohol. So total 1, 2, 3, 4 bonds. Yes. See double bond OH. Here, how many single bonds are present? 1. Here, 2 between the carbon. 1, 2, 3, 4, 5, 6, 7. And here one more 8. Option A 8. 8 single bonds are present in the molecular structure of propanol. Option A is the correct answer. Check it once whether it is correct or not. Yes. Option A, 8 single bonds are present in the molecular structure of propanol. Next question. The structural formula of propanol is, see the structural formula of the propanol means which contain the alcohol group, OH group is present. Here, see the option A, B, C and D. Here, in the option A, OH group is directly attached. So, which is wrong one. Here, double bond COH group is attached. Here, what we can say? COH group, C double bond O, OH. And in the option C, just see the option C, double bond O and H. Yes, this is the correct one. Here, there is O is directly attached here. So, this is the wrong one. Option C is the correct answer. Please note down the question. Next one. The number of single bonds and double bonds present in the structure of benzene molecule respectively. Here, the number of single bonds and the double bonds in the benzene. So, what is the formula? C6H6, right? Here, C6H12, sorry. Total 6 carbon atoms. 1, 2, 3. Just a minute. 1, 2, 3, 4, 5 and 6 carbon atoms. Just join this. Yes. So here the carbon, that is C6H6, right? So here H hydrogen is attached to the carbon like this, C6H6. Yes, but carbon that is having the 4 valency, but here only 3 is fulfilled. So I will add the double bond here. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. Total 4 bonds, and here. So this is the structure of the benzene here. How many double bonds and how many single bonds? The number of single bonds. Here hydrogen 6 bonds plus 1, 2, 3. Total 9 single bonds and 1, 2, 3 double bonds. So here option B, 9 single bonds and 3 double bonds. Option B is the correct answer. Please check it once again. Next question. The major component of compressed natural gas, that is CNG. Major component of compressed natural gas CNG is option A butane, option B ethane, option C methane, option D propane. Yes. Here the compressed natural gas, so that contain the methane. Methane gas is present. Option C methane. Please note down the answer. The major component of compressed natural gas is methane. Option C, methane. The common molecular formula of both hexene and cyclohexane is, the common molecular formula for hexene and cyclohexane. Cyclohexane formula is, hexene means which is having the double bond. Here C6H6 means that is the benzene. C6H14 means 1, 2, 3, 4, 5, 6. H14 means just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Total here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So here it is not a hexene because hexene means there should be a double bond, right? Then check it one, C6H12. 1, 2, 3, 4, 5, 6. Hexene means double bond should be there. And H12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. But here you should add a double bond because C6H12 which does not fulfill the carbon valency. So here we'll add the double bond. So H here. 1, 2, 3. Only one H here. And H. Here also H. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is the hexene because double bond is there. So this is the hexene and cyclohexane. Cyclohexane also having the formula C6H12. So the correct option is option C, C6H12. That is hexene and cyclohexane. Option C is the correct answer. Next question. The name and molecular formula of the unsaturated hydrocarbon having general formula CnH2n and containing 3 carbon atom is CnH2n, unsaturated hydrocarbon, which is having the formula CnH2n. See here, C3 is given, 3 carbon atom means C3H3 into 2, that is C3H6. C3H6 means C3H6. So that is not a cyclopropane. Cyclopropane is the saturated hydrocarbon, and unsaturated hydrocarbon, that is propene. Option D, C3H6. Option D, propene, that is C3H6. So you can check it, C3H6, double bond, 1, 1, 2, 3, 4, 5, 6. Right. So this is the C3H6, that is the propene. Next question. The functional groups present in propanol and propanol is propanol, that is the alcohol group, OH group. Propanol, propanol is the OH group. Sorry. In the first question also, sorry for the wrong information. Propanol, that is the CHO group. Okay. Propanol, that is the CHO group. So means CHO means aldehyde group, propanol. So in the both question 1 and question 2, I had given the wrong information. Sorry for that, because propanol structure is given. So I told you that is OH group, not OH group, that is the CHO group, aldehyde group. Okay. So aldehyde group, if aldehyde group is attached, that is, so C double bond OH. So like it is represented. If the alcohol group is there, OH group is directly attached here. So propanol means, so the OH group, propanol means aldehyde group. Okay. So sorry for the wrong information. Please change it once again. Option A is the correct answer. That is OH and the CHO. Let's check the answer. Option A, OH and the OH means propanol. That is the alcohol group. Propanol means that is the aldehyde group. Okay. The molecular formula of 3 carbon compounds which are in homologous series are C2H6, C3H8, C4H10. The suitable formula for this compound is, see here, C2H6, C2H6, C3H8. See the pattern, C4H10. Here, just apply the CnH2n formula to CnH2n formula means C2H4 it will be. CnH2n plus 2. Okay. Here C2 plus H2 plus 2, that is CnH2n, 2 into 2, 4 plus 2, that is 6. And 3. 3 2s are 6 plus 2, 8. So it believes the formula, that is CnH2n plus 2. Just do CnH2n. So just it will be a C2H4 it will be. Right. CnH2n minus 2. Just apply this formula. C2H4 minus 1, that is C2H3 it will be. So it is also not correct one. CnH2n minus 2. C3 I will take, C3H6, 2 into n, 2 into 3, 6 minus 2, that is H3, sorry, C3H4. So that is also a wrong one. The correct answer is CnH2n plus 2. Option D, So these all three homologous series, they are suitable for the formula that is suitable general formula, that is CnH2n plus 2. Option D is the correct answer. CnH2n plus 2. Please note down the question. An example for saturated hydrocarbon is, just check it. Saturated hydrocarbon means which does not have the double bonds, only single bonds are present. C2H6. 1, 2, 3, 4, 5, 6. Okay. Yes, C3H4. 1, 2, 3. Here only 4. So I will take the double bond H4. Here 1. So I will take the triple bond here. 1, 2, 3, 4. H here. And 1, 2, 3. So totally 1, 2, 3, 4 hydrogen, and here the carbon valency also fulfilled. Okay, so here triple bond is there, so it is not a saturated hydrocarbon. Okay, option B is wrong one. It is not a saturated hydrocarbon. Check the next one. C2H2. C2H2 double bond H, 4 valence is fulfilled, and here also 4 valence is fulfilled. So it is also having the double bond. It is not a saturated hydrocarbon. See the next one, C2H4, 1, 2, C2H4, 1, 2, sorry, that is C2H4. What I had drawn, that is C2H4 here. C2H2, that is double bond, triple bond. Yes, this is C2H2, C double bond, C, H, 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 H. Total 4 hydrogen, C2H4. So in these three, what you can see the double bond or triple bond, right, in between the carbon atoms. But in the option A, you can't see the double bonds in between the carbon atoms, only single bonds you can see. So option A is the correct answer. An example for the saturated hydrocarbon, that is C2H6. Next one. Ethane with molecular formula C2H6 has 6 covalent bonds, 7 covalent bonds, 8 covalent bonds, and 9 covalent bonds. C2H6. 1, 2, 3, 4, 5, 6. So which is having the how many covalent bonds? 1, 2, 3, 4, 5, 6, 7 covalent bonds. Option B is the correct answer. 7 covalent bonds. Option B is the correct answer. Next one. Butanone is 4 carbon compound with the functional group carboxylic acid, aldehyde, ketone, alcohol. So in case of the alcohol, so the butanol will be there, and aldehyde, butanol will be there. So it is called as butanol. And if carboxylic acid present, it is butanoic acid. Like this it is represented. But ketone is present as a functional group. It is named as butanone. Okay, option C, ketone is the correct answer. Next question. While cooking, if the bottom of the vessel getting black on the outside, it means the food is not cooked completely. The fuel is not burning completely. The fuel is wet. The fuel is burning completely. What is the correct answer? The fuel is the fuel is the food is not cooked completely. That is wrong one. The fuel is not burning completely. The fuel is wet. That is also wrong one. The fuel is burning completely. So this is also wrong one. The fuel is not burning completely. That produces the black color carbon. So that is called as a that is a option B. So till now we have discussed some multiple choice questions. Now we are discussing the 1 mark questions as well as some short answer questions and long answer questions. Okay. Yes, let us start with the first question. Please note down the questions. Use of detergents is more suitable for cleansing clothes in hard water. Why? Use of detergents is more suitable for cleansing clothes in hard water. Why? Okay. Here, the detergents are more suitable for cleansing clothes in hard water because they do not form insoluble precipitates with the calcium and magnesium ion present in water. So in a hard water contains these calcium and magnesium ions present in hard water. Unlike soaps, which would react with these ions and lose their cleansing ability, making detergents more effective even the hard water condition. Okay, so that is the very important thing about the detergents. Please note down the answer. Next question. In a homologous series, the first member of hydrocarbon group has molecular formula CH4. Then find out the molecular formula of the fourth member and write 2 types of structural formula of it. Here, in a homologous series, the first member, so that is CH4. Okay, find out the molecular formula of the fourth member. So molecular formula of the fourth member means that is having the 4 carbon atoms, and write 2 types of its structural formula. So here CH4, that is C1 means CnH2n plus 2 formula will apply for this. So C4H10. So that is the butane. C4H10, that is the butane. The 2 types of the structural formula is, first thing is C4H10, 1, 2, 3, 4, 5, sorry, 4, only 4. C4H10, 1, 2, 3, fulfill the hydrogen valency by carbon valency by hydrogen here, total 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. C4H10. So this is the one type of the structural formula of the butane. And one more type, that is 1, 2, 3, 4. Okay. Then here 1, 2, 3, 4. Carbon valency you have to fulfill 1, 2, 3, 4. 1, 2, 3, 4. Here 1, 2, 3, 4. 1, 2, 3, 4. Here, one hydrogen I will add here. Then 1, 2, 3. Okay. So this is the another type of the structural formula of the butane. I will show you once again. Yes. So this is the structural formula of the C4H10. So this is C4H10 and this one also. Please note, practice this C4H10. Next question. Identify the unsaturated hydrocarbons in the following carbon compounds and write their structural formula. Here, unsaturated hydrocarbons means which are having the double bond. Here, C6H6, that is formula of the benzene. So, which is having the double bond, that is also a unsaturated hydrocarbon. Let's check C5H10. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is not a unsaturated hydrocarbon. Second one is not a unsaturated hydrocarbon. And let's check C2H5OH. C2H5, 1, 2, 3, 4, 5 OH group. So this is the alcohol, ethanol. So here it is also it is not a unsaturated hydrocarbon option. Sorry, C2H5OH is also a wrong one. Then let's check C2H2. C2H2. C2 and hydrogen. Here one hydrogen and here also I will add one hydrogen. Means here 1, 2, 3. So this is a unsaturated hydrocarbon. C2H2 is the unsaturated hydrocarbon. So here write their structural formula. Unsaturated hydrocarbon structural formula you have to write. Benzene C 1, 2, 3, 4, 5, 6. Here 1, 6 carbon atoms and H hydrogen, 6 hydrogen. Okay, 6 hydrogen. Then double bond. So this is the benzene and C2H2, 1, 2. Here hydrogen, 2 hydrogen, 1, 2, 3, 1, 2, 3, 4. So triple bond. So this is the structural formula of the C2H2. Okay. Write the difference between esterification and saponification. Please note down this question. Write the difference between esterification and saponification. Here, the difference between the esterification and saponification. Saponification is a process of preparation of the soap and esterification is a process of preparation of the ester from the carboxylic acid and the alcohol. Here to reactants are required? Carboxylic acid and alcohol. Saponification is somewhat different from esterification since an ester responds to alkali in this situation. In the esterification reaction, an acid reacts with alcohol in the presence of concentrated H2SO4 to form an ester. Okay. End products are carboxylate ions and alcohol. End products are ester and water. The reaction does not require heat energy. Here, the esterification reaction requires the heat energy. Please note down the differences between the saponification and the esterification. Next question. Write electron dot structure of oxygen molecule. Carbon atom does not form C4 anions and C4 plus cations. Why? Why it is not forming the carbon, not forming the anions and the cations? Why? What is the reason behind this? Okay, electron dot structure of oxygen molecule. So it is like this. Oxygen bonds by double bond O double bond O, O2 molecules. Here, carbon atom do not form the C4 plus cations and C4 minus anions because it would require a lot of energy to remove or add 4 electrons to the carbon atom. This is the first reason. C4 cation removing 4 electrons from the carbon atom would leave a cation with 6 protons and 2 electrons, making it highly unstable. And C4 anion, a carbon atom's nucleus with 6 protons would not be able to hold 10 electrons. So when it gained the 4 electrons, it is not, the carbon is not able to hold the 10 electrons. So that is the reason. Please note down this answer. Very important question. Repeatedly this question asked in different question paper. Okay. Next question. The general formula of cycloalkane is CnH2n and its first member cyclopropane, that is C3H6. Write the molecular formula and structural arrangement of the fourth member of this homologous series. Here, the fourth member of homologous series CnH2n, the fourth member of this series, that is C4H8, because CnH2n, C4H8. What is the structural arrangement? C4H8 structural arrangement is 1, 2, 3, 4 and 1, 2, 3, 4, 5, 6, 7, 8. But carbon valency which is not fulfilled here. So first you have to fulfill the carbon valency. Okay. C4H8. C4H8. Okay. 1, 2, 3, 4, 5, 6, 7, 8. Yes. So this is the structural arrangement of the C4H8. Next question. Write the two differences between the saturated and unsaturated carbon compounds. Here, while writing the difference, you should make the two columns, and in one column saturated carbon compounds and in the another column unsaturated carbon compounds. You should mention the difference in that column only, but I will give the answer in like this. Saturated hydrocarbons contain only single covalent bonds, while unsaturated hydrocarbons contain at least one or more or double or uh, triple carbon bonds. Saturated hydrocarbons, they contain only one single covalent bonds, and saturated compounds are normally not very reactive. Saturated compounds are not very reactive, but unsaturated compounds, they are more reactive than saturated compounds. So this difference you have to write it in a separate column. So you have to make this columns like this. I hope you know how to write this difference. So you have to mention the points here. Okay. Please note down the answer. Write any two differences between saturated and unsaturated carbon compounds. Write the structural formula of the following carbon compounds: benzene and butane. You have to write the structural formula of the benzene. Benzene formula already we know, already studied, right? Benzene C6H6. And butane. So that is C4H10. Butane formula is C4H10. So two types of the butane structure you can write. Already we have practiced that. Try to write the structure of benzene and butane yourself. Okay. ನೀವೇ ಬರೀಲಿಕ್ಕೆ ಟ್ರೈ ಮಾಡಿ ನೋಡೋಣ. Yes, this is the structure of benzene and butane. Next question. Write the structural formula of ethene molecule. Ethane, ethene, ethine, right? Ethene molecule means which is having the double bond. Ethane means which is having the single bond. Ethine means triple bond, right? Ethene which is having the uh, double bond. Ethene means two carbon atoms, and ethene, one, two, one, two. Like this you can write. One, two. So total, this is the ethene, two carbon atoms and two bonds, that is called as a double bond, and C2H4, that is the ethene. Okay. Let's check the answer. Yes, C2H4. Next question. What are structural isomers Write the molecular and structural formula of butane. What is the catenation? And write the general formula for alkenes. Here, please note down this question, very important question, and this was asked in different question paper, old question paper. Okay. Yes. Compound with identical molecular formula but different structures are called structural isomers. The compounds which are having the identical molecular formula means same molecular formula but they are having the different structures. For example, butane C4H10 C4H10 which is having the different structural isomers C4H10, right? So but the formula is same for all these structure, that is called as a isomers or called structural isomers. Next question. Write the molecular formula and structural formula of butane. Molecular formula, that is C4H10. Butane is C4H10, and molecular formula. So this is the molecular formula, structural formula 1, 2, 3, 4. 4 butane and H10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. C4H10. Okay. Next question. What is the general formula of alkenes? Alkenes general formula, that is CnH2n. CnH2n is the general formula of alkenes, and catenation is the self-linking of atoms of an element to create the chains and rings. Detergent be used to test the hardness of water? Give reason. So why we use the detergent to test the hard water? No, detergent cannot be used to test the hardness of the water because it easily react with both hard water and the soft water. Okay. So, but we can use the soap because soap does not form any cleaning activity in the hard water. So, we can use that. Okay. Next question. This is the same question. What are structural isomers? Very important questions. And the two structure of butane molecule, two types of the isomers of the butane molecule. How would you distinguish experimentally between alcohol and a carboxylic acid? So this is the new question. How would you distinguish experimentally between the alcohol and a carboxylic acid? Please note down this question. Esters are most commonly formed by reaction of acid and alcohol. But carboxylic acids, they are not formed by the reaction of acid and the alcohol. What are structural isomers? Name the first member of alkanes that shows the structural isomerism. The first member of the alkanes that shows the structural isomerism, that is butane. So please practice the structure of butane. Next question. Write the differences between saturated and unsaturated hydrocarbons and write the molecular formula and structural formula of alkene having 5 carbon atoms. Here, write the differences between the saturated and unsaturated hydrocarbons we have studied already. Write the molecular formula and structural formula of an alkene having the 5 carbon atoms. Okay, alkene that should have the 5 carbon atoms, 1, 2, 3, 4, 5, and double bond should be there. So alkene C5, H10, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. Okay, alkene. What is the general formula of the alkene? Here, CnH2n plus 2, that is the formula of the alkane. Alkene here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. CnH2n, that is C5H10, that is the formula of the pentene here. So this is the alkene because double bond is there, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Total 10 hydrogen atoms are there, 5 carbon atoms are there. So this is the structure of the alkene. Alkene which is having the 5 carbon atoms. Yes, this is the alkene which is having the 5 carbon atoms. Next question, which is same question. Carbon atom does not form C4 minus anions and C4 plus cations. Why? How can ethanol be converted into ethanoic acid? Please note down this question. This one is already we have studied. This is the important one. How can ethanol be converted into ethanoic acid? Here, ethanol. So this is the ethanol. When it is oxidized with the alkaline KMnO4 and when it is heated with this alkaline KMnO4 which forms the ethanoic acid. So this is the representation of the how the ethanol is converted into ethanoic acid. Or you can use the acidified K2Cr2O7, potassium chromate. Potassium permanganate uh, react ethanol with an alkaline potassium permanganate solution to form the ethanoic acid. Explain the addition and substitution reaction with the help of examples. C2H6 undergoes the substitution reaction but not the addition reaction. Why? Very important question. Unsaturated hydrocarbons add hydrogen in the presence of the catalyst such as palladium and nickel to give the saturated hydrocarbons. Catalysts are substances that cause the reaction to occur due to or proceed at a different rate without the reaction itself being affected. This reaction is commonly used in the hydrogenation of vegetable oils or using the nickel catalyst. Then vegetable oils generally have long unsaturated carbon chains while animal fats have saturated carbon chains. So this is the example. Next, the saturated hydrocarbons are fairly unreactive and are inert in the presence of most reagents. However, in the presence of sunlight, chlorine is added to the hydrocarbons. In very much fast reaction, chlorine can replace the hydrogen atoms one by one. This is called as a substitution reaction. First one is the addition reaction and this is the substitution reaction because one type of atom or group of atoms takes the place of another. A number of products are usually formed with the higher homologous alkanes. So this is the example. These all reactions are very important. So last one, because it is a saturated hydrocarbon, meaning already it has the maximum number of hydrogen atoms it can hold. So it is cannot be more atoms to its structure. What is the question here? C2H6 undergoes the substitution reaction but not the addition because already it is a saturated hydrocarbon, meaning already has the maximum number of hydrogen atoms. So it can hold, so it cannot add the more atoms to its structure. So that is the answer. Okay. So dear students, I will stop the class here. We will continue in the next class. Okay. Thank you.